Welcome. Today we're looking at 7.3, absolute value equations. We'll do both parts today in one video. So an equation, obviously we've been working with expressions so far, or functions, which don't have an equal sign in them. These will have an equal sign in them, so we will actually be solving for the value of a variable. So evaluate the following. Absolute value of minus 10 is 10. Absolute value of 10 is 10. Absolute value of negative 2/5 is 2/5. Absolute value of 0 is 0. Absolute value of negative root 13 is root 13. Root 13. Alright. There's our warm-up. So consider the absolute value function y equals 3/4 x minus 3. Determine the x and y intercept. So the y-intercept is the easiest one. Plug in 0 for x and we get x equals y equals the absolute value of 3/4 times 0, which is 0, minus 3. Okay, so we're taking the absolute value of negative 3, which is 3. So we're going to have the point 0 and 3. Oops. Okay, so here's where we were. So there is your y-intercept when x is 0. And now your x-intercept when y is 0, so we have 0 equals 3/4 x minus 3, absolute value. Okay, so you can figure out where that's going to be positive and where it's going to be negative. And so set it equal to 0 and then move the 3 over to the other side. And then multiply by 4. So 3x equals 12. Divide by 3. X equals 4. So when x equals 4, this whole thing is 0. So that is going to be your x-intercept. So at 4 and 0. So we have these two important points, the x-intercept right here, and the y-intercept at 0 and 3, which is right here. Now this thing is linear, so we can guess that it's going to go like that, and we would be absolutely right. So it's linear with a slope of 3/4, so that's rise over run, and an intercept of minus 3, but we know that that is only going to be positive 3 because we're always taking the absolute value. All your y values are going to be positive. So slope of 3/4, rise over run, so we can go 1, 2, 3 up, 1, 2, 3, 4 over, and we'll always find a new point. And obviously that's mirrored over here, 1, 2, 3 up, 1, 2, 3, 4 over. There you go. So there's your graph. Oops. Where's my line? There we go. The graph goes like that. And like that. And we're done. State the domain and range. Domain is x such that x is an element of the reals. We can use any value in the world we want for x. And y such that y is greater than or equal to 0, because again it's absolute value. Your results are always going to be positive there. Express as a piecewise function. So here's the turning point. If it wasn't an absolute value function, instead of having this piece here, this piece would just go on forever down here into the negatives like that. Okay, but since we can't have negative y values, everything pivots on this point, or hinges right there on this intercept. So as a piecewise function, here we just use the positive version of this function. So when y equals y, we find the value of y by 3/4 x minus 3, just using the equation inside. But we only do that because this is the 3/4 x minus 3 line. This is the negative 3/4 x plus 3 line. As you can see, it has an intercept of positive 3 and a slope of negative 3/4, so 4 over and 3 down. So negative slope, positive slope. So those should be reflected there. So from 4 up, we use this equation. So we do this one when x is greater than or equal to 4, because that's our intercept. And we use the negative version of it. Oops, and that should have an x there too. The negative version of it, which is that, whenever x is less than or equal to 4. So on this side of 4, we use this equation because it's negative slope, positive intercept. Alright. I'm going to skip that one, move on. Solving absolute value equations. So here you go, consider the absolute value equation, absolute value of x equals 10. Use the number line to geometrically solve the equation. How many solutions are there? So this one, the absolute value of x equals 10. So basically, any value of x that is 10 spaces away from 0. So this could be a solution because we 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces away. This one, even though it's negative 10, we're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces away. So our distance is 10 in either case from that thing. So there are two solutions. How many solutions are there for this equation, this equation? So there are two, there are two. For this one, there are also two, as long as b is not 0. Because if b was 0, that's a distance of 0, there would only be one solution, and it would be here. But for any value b, as long as it's not 0, if it's away from 0, so b could be, say, 4.5. This is a distance of 4.5, but this is also a distance of 4.5, so there would be two solutions there. What are the solutions? Well, for the first one, plus or minus 5. For the second one, plus or minus 8. And for the third one, plus or minus b. Make a conjecture about the number of solutions for an absolute value equation. There will always be two, except for when x equals 0, because this represents a distance of 0 away from the reference point. And of course, if you have a dot there, there's not two solutions there. Okay, so there you go. Is it possible to have an absolute value equation that has no solution? Yes, it is possible. Under what conditions would this happen? It would be possible to have an absolute value equation with no solution if the absolute value of a variable was less than, not equal to, but less than, 0. Because you can't take the absolute value of something and end up with a number less than 0, which would be a negative number. Because you take the absolute value, it's always positive. Discuss how to use the following definition of absolute value to solve absolute equations. Okay? We'll just get practice with this later together. Use the definition of absolute value. So there are two cases to consider. The expression inside the absolute value symbol is positive or something. I better double check. Positive or 0. Or the expression inside the absolute value symbol is negative. So there's always going to be two cases. We have to consider them both. Alright, so solve a simple absolute value equation here. The absolute value of x minus 3 equals 7. There are two cases. We know that inside x minus 3, when x is 3, this is our turning point. Okay, so if x is anything bigger than 3, inside this set of brackets is going to be a positive value, and we just use the positive version of this, and then we solve and we get x equals 10. But if x is smaller than 3, so say x was 2, 2 minus 3 is negative 1, and we would have a negative value inside the brackets, and we would have to take the negative of that expression to turn it into a positive, which is what the absolute value brackets do. So then it would be the negative version of it, which is negative x plus 3 equals 7. Negative x equals 7 minus 3, which is 4. And of course x equals negative 4. So these are the two solutions that would make this thing true. So let's try them. If x is 10, we have 10 minus 3, the absolute value of, equals 7. So the absolute value of 7 equals 7. 7 equals 7, true. This one, negative 4 minus 3 equals 7. Absolute value of negative 7 equals 7. And of course we know that when we take absolute value, it becomes positive because it's just a distance. 7 equals 7. And we're done. So here's your turn. Go ahead and try to solve it. Answer will be here when you get back. Okay. There you go. X equals 4 or x equals 8. So there it is. So it's the absolute value function of 6 minus x, which is this big V, and where it intersects with the line y equals 2, which is this line. So there's your two solutions, 4 and 2 and 8 and 2. Alright. Come on, you. So here's a quick warm-up. I'll leave you to do it. This is stuff you should all be able to do pretty quickly. At least this first part, anyway. This one, two solutions, x equals plus or minus 13. Two solutions, x equals plus or minus a half. One solution, x equals 0. And no solutions, because the absolute value of a number can never end up negative. So let's solve a problem. Computerized process controls the amount of batter used to produce cookies in a factory. If the computer program sets the ideal mass before baking at 55 grams, but allows a tolerance of plus or minus 2.5 grams, solve an absolute value equation for the maximum and minimum mass M of batter for cookies at this factory. The maximum and minimum mass, okay. So we know they're going to be 55 grams, but they can be up to 55 plus 2.5 or as low as 55 minus 2.5. Okay? So the mass of the cookie is represented here. So there you go. The maximum and minimum mass M can be thought of as the mass of the cookie minus 55, but we're going to take the absolute value and then set it equal to that tolerance there. So you can use a number line if you want to. It's a nice simple way to look at it. The maximum mass, we can go up to 2.5 units this way away from 55, or 2.5 units the other way away from 55. Here's your turn. Go ahead and give it a try. The answer, as always, will be here when you're done. There you go. I trust that it went well. So we'll move on to the next example here. Absolute value with an extraneous solution. Extraneous means a solution that seems like it's an answer, but doesn't actually work in the equation. So here's our equation. The absolute value of 2x minus 5 equals 5 minus 3x. Now again, we have to consider the two cases where 2x is greater than 5, so inside here is positive, and we would use the positive version of this thing. Or the other possible case where 2x is smaller than 5, so when we subtract 5 we get a negative in there, in which case we have to use the negative version of the absolute value. So these are the two possibilities for this equation. So 2x, add 3x, and we get 5x. Add 5 over to the other side, 5x equals 10. Divide them both by 5 and we get x equals 2. So let's solve this one. Negative 2x plus 5 equals 5 minus 3x. So let's add 3x over here. So we get x. And then let's subtract 5 from both sides, and we get x equals 0. So let's see if these are true. So this first one, let's plug 2 in. Absolute value of 2 times 2 minus 5 equals 5 minus 3x. So the absolute value of 4 minus 5 equals 5 minus 3 times 2. Now, this is the absolute value of negative 1 equals 5 minus 6. So 1 equals negative 1. That's not true. So this is an extraneous solution. Another way to think about it is, if you look at what's inside the absolute value brackets, and we set that equal to 0, this is always the turning point in our graph. Oops. So 2x equals 5, x equals 5 halves. So basically, at greater than 5 halves, the inside of the brackets is going to be positive. At less than 5 halves, the inside of the brackets is going to be negative. Now, this solution, x equals 2, is smaller than 5 halves. So we know already that it doesn't fit properly in the domain that would allow us to use the positive version of this function. 0 is less than 5 halves, which is good because that's why we use the negative version of this function, because we're below 5 halves here. And let's see if this one ends up working. So we have the absolute value of 2 times 0 minus 5 equals 5 minus 3 times 0. So 0 minus 5, the absolute value of that equals 5. Of course, the absolute value of negative 5 is 5. and we get 5 equals 5. Awesome. Everything's good. So here's another your turn. Go ahead and give it a try. There you go. X should be 2. If you found another solution to it, it's probably an extraneous solution that doesn't actually work or fit in the proper domain. Here's one with no solution. Now, this is going to be quick and simple. The absolute value of 3x minus 4 equals, now subtract 12 from both sides, negative 3. It's impossible to take the absolute value of something and end up with a negative number. So this could never happen. So right away, just by inspection, we can say, hey, that's not possible. This thing has no solution, so it's just the empty set. The empty set is just a set literally with no values in it. Here's another your turn. It's quick and simple. The answer is the empty set, or an empty set of brackets, literally. Okay. So go ahead and try this one and the next one back in the classroom. I'll verify your answers if you want. That's it for today. See you later.